Hi, um, today I'm going to be talking about how to train your AI model. As you begin that machine learning or AI project, there are a couple of things that you have to, have at the back of your mind. In other words, there are some uh, perspectives, some theoretical understanding that you need to have at the back of your mind while engineering your machine learning project right from the very beginning. Otherwise, you are likely to miss it. There's a recent research that was conducted by MIT that revealed that about 95% of AI machine learning projects, uh, specifically generative AI based projects, they fail. And so that is a lot. 95% of project failing is a very, very big deal. So, what are the things that make machine learning projects, AI projects, to fail? The study went on to bring up different reasons from the approach that is being applied to it and the nature of the AI models that are being used and a lot of details, right? And personally, from experience, I also have some from the engineering point of view, talking specifically uh, from looking under the hood at the real engineering, the whole life cycle of the project. From my experience, I also have some reasons why I know or what I think are some of the reasons why many machine learning project or AI project fail. And what we're talking about today is actually at the heart of some of the reasons why AI and machine learning projects are notorious nowadays for failing a lot. And that is having an understanding of, having like a global view, kind of having like a bird's eye view of the whole process of a machine learning project. It's easy to just get lost in the library that you're using, whether you're working with neural networks, with PyTorch, or any other framework, or maybe you're doing traditional or classical machine learning using scikit-learn, um, or whichever approach you're using. Um, it's easy you know, to get lost in the trees and then lose sight of the forest. It's easy to get lost in the trees and then lose sight of the forest. So, what I'm talking about here now is at the heart of machine learning and AI projects. You need to have that world view about what training a model is about. And that is a very important question. So, what is it about? You need to see an AI model as a mathematical formula that is realized from data. You need to see an AI model as a mathematical formula that is realized from data. That's very crucial. That it is realized from data is very, very crucial, because then you begin to understand that the data itself and the way you manipulate the data, the way you prepare the data, the way you sample the data has a very, very important role to play in the whole machine learning or AI project. Is very, very critical. And so that's what we'll be diving into right now. how do you train an AI model? What is the worldview of the AI model that you're training, which should inform the way you gather your data, the type of data that you gather, how you sample the data? Because for every software project, including AI projects, including machine learning projects, there is a problem that we seek to solve. Be it in e-commerce, maybe you're trying to predict um, customer behavior in order to improve user experience. Be it in fintech, maybe you're trying to do fraud detection. Be it in general security, you're trying to do anomaly detection. There is a problem, a real world problem you're trying to solve. And then the way this machine works, the way the AI model, which I said you can picture as a mathematical formula, the way it works is that it seeks patterns in the data. So it is all about the data. It looks for patterns in the data, and then it adjusts weights, and then those weights, after it has trained and learned those patterns in the data, the formula is well defined and stabilized, then those weights are frozen, and during inference, when it's deployed to production and you begin to use it, then it is that function, that mathematical function that has evolved by looking at the patterns in the data, that begins to run, right? So it's just like how you would have written a mathematical formula by yourself with your hands, informed by some knowledge that you have about how that formula should be written. In the same way, in AI and machine learning, this time around it's automatic. It is not you that is prescribing the mathematical formula, but rather the AI model is evolving the mathematical formula by itself. It's self-evolving mathematical formula. So you need to have that, that forest view, that bird's eye view of it. Like I said, because it's easy to get lost in the trees and lose sight of the forest, of the big picture. So having that at the back of your mind, so hold that thought at the back of your mind right now, that we are trying to solve a real world problem. That's number one. Number two, the data is the key. The data, the mathematical formula, the essence of the model evolves from the data. Number one, the project itself. For the project not to fail, we need to keep at the back of our minds that the project is aimed at solving some real world problem. Bear that in mind, don't lose sight of it. We're not just doing this project for the sake of it, not because we want to use the next shiny thing, we want to get into the next hype, because there's a lot of hype out there about AI and machine learning. You should be purpose driven, and then so you should have a real problem that you want to solve with AI machine learning, and have a clear definition of that problem. You should have proper business case for the problem. So it should be a real problem that you really have, a real problem that has been well defined. So after you're done with that, you also remember another point, that the data on which the model is trained is also very, very critical. So now you have two things. You have the real world problem, which is real, and then you have the fact that you need the data. So that data need to model the real world. So the data on which you're training the model needs to be a picture of the real world of your problem. So you have a problem space in your business, or you have a problem space. Maybe it's a client. The client that has brought you in to build this AI model has a problem space, has a real business goals that are clearly defined, real world issues that the model needs to solve. And now you need the data from that world, and the data has to correctly mirror the world. So when there is a deviation, or when there is disparity between the problem that the AI project is meant to solve, and the data that is being used to train the model, then that project has failed from beginning. That project has already failed. So that's how critical it is. So if, for example, uh, in fintech space, you you want to build fraud detection system that will detect fraud, right, in your pipeline of transactions. And then instead of using data that resembles the real world of your own system, you have your subsets of the fintech space where your company plays, where your business plays. There is some peculiarity about the type of data, financial data that you receive. Maybe, for example, you are operating in the cross-border payments realm, and then the type of data that you have is data from maybe MT101 Swift data, right? Like payments in the Swift network. That's the type of data you have, and that is the type of data that operates in your world. Recall we said you have a problem in your business world, in the world of your business, and in the real world of your business. And then you need to ensure that it is the data that comes from that your real world of your own business, the peculiar world of your business, is that data that you use to train your model. So, so let's say that is your real world. You are in Swift cross-border payments, dealing with empty protocol, empty files, payments data. That's what you have. That's what you deal with in your business. But then you go and use data for someone who perhaps is doing maybe switching, maybe acquiring, processing, where you begin to, in which case you are processing ISO 8583 protocol packets and data that comes in, those stream of bytes that you serialize maybe to XML, and the data points that, so maybe you get that type of data, that's what you have access to, or perhaps for whatever reasons, maybe there's a disconnect between the engineers working on the project and the business, and so you just get hold of financial data. Because it is just financial data, you think, okay, it will work, and you use it to train your model. Then your project is bound to fail. It's bound to fail, unfortunately, because you are training on data that does not model the world of your problem, of your business problem. So that's the first thing to take note of. So, but then that brings into question something very serious, which as a professional in AI machine learning, as you have practical experience, you deploy models to production, and you have business expectations for AI projects that you work on, and you have to provide business justification to management, and or maybe your clients who you are helping to adopt AI. You need to ensure that they are satisfied and they don't have bias or remorse in your project. Another thing that you realize quickly is that it is impossible, it's mathematically impossible for you to get 100% or of your real world data. It's not possible for you to get your real world data because there is an infinite probability distribution for your real world, because there is an unlimited fashion and shape and form in which your real world data can come. So so what you have is dataset. You have a dataset which is a sample of the real world data, the ideal data of your real world. Get that? So now you need to make sure your data maps with the real world. That's the first requirement. But then comes a dilemma, which is the fact that whereas you have to try to make sure that the data on which you're going to train your model it resembles the world of the business in which the model is going to play when it's deployed. Yet the dilemma is that it is mathematically impossible to get all the data that you need in all the forms in which they can exist in your world, the real world of your business problem. That is a major issue in machine learning project, because it's different from all other types of software engineering project, because it is not functions that you write and prescribe rules. It's not rules based, rather it is self-evolving from the data that the model is trained on. So that's why it is different. So we are at a very important phase, an inflection point in the software engineering history of mankind, because for the very first time we begin to design systems like this that are not very deterministic, because then the control is no longer in the rules that we're able to write, it's no longer in the code that we write, but rather in the data that is trained and that trains the model. So the rules evolve from the data. So that's why it's so critical. So how do we solve this problem? How do we solve this problem? There's a solution for it, and that's what we're going to be looking at. We just look at a few things to keep in mind in this video. Subsequent videos we're going to go into coding and then look at how to implement some of them. But it's very, very important, like I said, like I've repeated severally, to have at the back of your mind the salient nature of this, and how critical this is. So you need to have it at the back of your mind, because I see a lot of engineers who go into AI machine learning, they're only thinking about the framework, using the same approach of traditional software engineering to go into AI engineering. They just think about the how to write the code, how to use PyTorch, how to use a TensorFlow, how to, and then forget about these rules. So there are new rules. This is a different game. So you have to play the game by its own rules. So these are some very, very critical rules of this game. So you don't want to make the mistake of using the rules of soccer to play hockey, or the rules of hockey to play soccer. So that's why these are like ground rules that you need to know about, and that you need to keep at the back of your mind as you embark on AI machine learning project. So I'm going to share my screen, and then we're going to look at some of these principles, and then how we go about them. So kind of like set a foundation for the technical sessions that we're going to have later, where we are going to go into coding. So do well to turn on notifications. So just subscribe, and then turn on notifications, so that when the technical sessions where we begin to go into coding when the videos come up, so that you will be notified. So quickly, we are going to look at this now. So, so like I've explained, so we have the real world, all right, and so this is the model of the real world of your business problem. So in the real world of a business problem, you have P data. P data is what you have, where you have like let's say we're using a classification project for as an example. So where you have labeled data. Typically, the labeled data is like the Y, right? Y will be a vector typically, and then Yx will be a matrix of which you have different rows and different rows which are different observation. So your full data set will be the X, right? So P data will be the X, and then the Y P data X is a matrix, or a TensorFlow is a tensor, or from you can think of it like a multi-dimensional array, right? And then while the Y will be a vector or a flat array. Okay, so the Y will be kind of like the labels. So this is from the perspective of supervised machine learning project. So P data, like I've explained earlier, is actually like all possible probability of having in this business world all types. Let's say, like I explained earlier, you're doing a fintech project, maybe it's an anomaly detection, fraud detection project, all forms in which financial data in that your business can come in all forms, all amounts that can come, different variables. You know, you have different features, right? Let's say you are collecting the maxed pan, you're collecting the merchant ID, and also you are collecting the acquirer ID, which and then also maybe another data point you're also collecting is perhaps you're collecting like some things about the username, collecting of which some of them will be maxed and some complexity coming in there, but then we are collecting those data points which are going to be like the features and going to be think of them as columns in the matrix of X. So you can imagine the probability of having all different forms, different types of amounts, and different transactions happening at different times, time of day, and all types of things that can come in. Then you also begin to factor in noise and all that. So that's why it's mathematically possible for you to have this ideal data, which is the P data of your real world, that we just say all forms of data that can ever come into my system have it. It is not mathematically possible, but then that is what is expected. Why? Because, like I said, in machine learning, the function evolves. In rules-based programming that we have been used to before the advent of machine learning, you write the function. Everything is deterministic, but this time around, the function has to evolve. So for you to really have 100% confidence, you need to have all forms of data possible. You need to have all ground cover. That is it, right? Yeah, mostly, especially in mission critical situations. So this subject is very, very important because it brings up all sorts of issues, like reasons why, some consideration that you begin to have, when you want to use AI in mission critical environments. You need to be sure, because it could be be the difference between life and death for somebody, right? So that is P data. So I've explained that it's not, you can't really get it, but then typically it means that the probability of getting Y given X. So that is the probability of getting y given x. So the y, like I said, is the label, the classification. Let's say it's a classification problem, like anomaly detection or fraud detection. Let's say is fraud, is not fraud. So y is like it's the labeling of it being fraudulent or not being fraudulent, being suspicious or not being suspicious. So the probability of each y. So if it is binary, just like it is fraudulent or not fraudulent, true or false, to be 2. But then it could be multi-class. It's also possible you could have like maybe 10 classifications, type of problem. And so for each of them, the probability for each of them given X, which is the data set, right? And then also the probability that the data even exists. So this is the existential perspective to it. So the probability that it even exists at all, right? So like you recall I said that the data has to model the real world, right, of your business. So it shouldn't be unrealistic data. So that is why you can see that the maths, it checks out, right? Because then you still need to factor in, you won't just factor in the hypothesis, you also have to factor in the possibility of the data being even real, right? Of it being in existence. So this is the real world, but we can't get the real world. So what do we do? Right? So what we have is not the real world. What we have is this: we have the training data, which is which is our D train, right? So this is what we usually have in our project, and this is what we live with, because we cannot use the whole data. We can't even come up with it, and that brings up the context and the concept of sampling, right? So you sample from the distribution of what is real in your real world. So you just work with a subset. So you have a D train, and then in D train, so you have different observations. For each observation, you're able to get in your data set. So this is kind of like the method to the madness, right? So it's good to have like this foundational theoretical understanding of what is happening under the hood, so that you will be doing your data collection and your data aggregation in the right way to succeed, because the data is very, very, very critical. So it's good to have this foundation at the back of your mind. You may already know how to use the tools, use pandas, use different tools to get this data, right? You do all the data engineering to get the data, but then it's not just getting any data. You need to make sure you play the game by its rules, the rules that guarantee success. So this is it. So you have the D train, and then you have you just have different rules, and then they are labels. So you have like the X1 is label, so maybe one row and it's label, and then all that. So you just make sure that at this level, that for each observation that you have, the xi that you have, that you are giving it the correct yi, right, the correct labeling. So this is what you have to cope with. And yeah, and then there are also some other interesting things that begin to come into play that you begin to think about. um, it is believed that this data sets, though it is not the full world of our business problem or the business reality, that it is independent and identically distributed. So this is where you begin to deal with our probability distribution, right? So and which is kind of cool, and we're going to work when we go into coding in subsequent videos. We're going to look at them, and it is if you are an experienced machine learning engineer or AI engineer, you will know that this is very critical, because it comes into play for very, very important things, like when we're going to talk about data drift and feature drift, because it is so critical, the data on which you train, so much so that if the nature of the data or your business world changes from the way the picture of your business world was when you trained your data, then your model begins to fail. That's what is called model drift, right? So it will now be a case of model drift occasioned by feature drift, right? So which is occasioned by data drift. And how do you figure that out? Through the probability distribution and some other things about, the distribution of your data, right? So, and there are some tools that you can use to do that. And this is even without looking at the model yet, being model agnostic at this point, but then still just looking at the data that you now have, the picture of the world in which your project now exists. You have to look at it and be sure that it is distributed. So it's very, very critical. So it being independent and identically distributed. So it has to be independent and then it has to be identically distributed. So that identically distributed part of it is what I've stressed. It's very important, the distribution of the data. Let's say, for example, you have maybe you're training your data for fraud detection, and the type of users, the nature of the users in which you did your that are represented in your data set, perhaps users that maybe do not transact in the middle of the night. Maybe they only transact, during the days, maybe in the mornings, the afternoons, and maybe they don't also transact in the evenings. And then also, maybe they are low income earners, and so there's like maybe like the average amount that they spend is maybe in the thousands. And then maybe you go into production, you trained with that, and then you go to production, and that's the subset of users you have. That's the world of your business for now. But then maybe things change. Before you know it, the demographic of your users begin to change, and the behavior of your users begin to change, and you don't know it. But all you know is that we built an AI model. We're done with this project. It's doing well. People are happy. Our users are happy. We're getting returns from it. We're getting praise from it. And then it just succeeds for 6 months. And then after 6 months, you begin to see that people start complaining that is giving a lot of false positives, a lot of problems are happening. But then it's the same model, not to change. And then if you do not have this understanding, this foundational understanding about the importance of the data and how the distribution matters, you may not be able to tell, not know what to do or where to look to be able to tell what is causing the problem. And so that is one reason why this is very, very critical. So typically, so you have to be on guard. And one thing I tell clients is that you are never done with a machine learning project, because even in traditional software engineering, you continue to develop, you continue to maintain, but then it's even more so now for machine learning project and AI project because of it is dependent, it evolves from the data, and the data is very volatile, and data can change faster than even business rules, right? Data can change faster than business rules, but traditional engineering business rules can evolve, so you have to be agile. So user needs can evolve, so you have to keep evolving, you have to keep innovating, which we used to think is fast paced and keeps you on your edge. And then but then in machine learning it's even more so now, because things can change. Your business rule can remain the same, your user needs may remain the same, right? You don't have new business, you're not changing your business model, your users don't have new needs. But the fact that the type of users change alone can just make your models begin to fail, because then the features have changed. So it's so critical. So typically what you do at this point is you begin to you keep your ears down, you have some observability, to observe as the feature changes and all that. There's different techniques you use at this point, to maybe fine tune the model instead of doing a retraining, because it could be very, very expensive to have to go and train the model again and all that. So it's actually interesting. So that this is very important. And then another thing that comes into play then that is that we have to now, even in the training, in training the model, there are some things some practices that we have to follow. They have different advantages and different disadvantages, and we have like the train test split. Typically, you don't just train your model with all your data, right? Because you have to evaluate it. You have to evaluate it. You have to do test-driven development, right? So you need to see how the model is doing, because the model AI project, building an AI model, is an iterative process that is so iterative that you need to have test data beyond your training data. And you can't test with the same training data, because when you do that, you are not going to get true accuracy, because if you if you test the model on data on which it was trained, then it will, you know, might would have like memorized it, and then it knows it, and then it just give you answer for that, which is like is overfitted to it. So you don't want that. So that's why it is important you have to do splitting. So, and this is a very crucial thing that you have to do. Most of these libraries, whether it's sklearn, scikit-learn, or it is pytorch and all that, they have utilities by which you're able to split your data set. So again, you split it. So you can imagine, now you don't even have the whole world of your business, the data for the whole world of your business with you. Yet this part that you have, you still have to split it. So you can see how delicate machine learning projects are. The data is critical, but then you don't even have all that really mirrors your business world. Yet the one you have, you just can't use it like that. You still have to split it. You need to have subset of it that you use for test. Now that's there. It has its advantages, and it also has a downside. We're going to go into it, go deeply into it when in subsequent videos, where we are going to code and then do some visualization and then look at them. Plot some graph to see how the data things are changing, so you can like visualize it and see what's going on, or why some of these practices are done, and to be able to get things right at the data level and at the training level for your model. And then we also have cross validation. Cross validation. So cross validation takes care of the downsides that we have with train test split. And then it takes care of that, and it's quite interesting. We will go deep into it in one of our episodes. And then so these are the test side of things. These are the test side of things, because even the testing is critical. So the train test split helps us to ensure that we have data to test, to validate, all right? Data with which to validate our models, which is very important because it's iterative. For example, you can't tell, there's no rule of thumb. If in case you don't know, let me tell you now. There's no rule of thumb by which you will know, for example, in a neural network, how many layers you should have. There's no rule of thumb by which you will know that. You will have to iteratively, so when you iteratively, and then you see, okay, it's not good, you are far off, then okay, fine, I need to add some more complexity to it. You increase the number of layers. So it's something that is iterative. It evolves, and then you observe, and then you change those parameters, the number of layers, the regularization term, and everything that you are, in fact, activation, all those parameters that you bring into play, you can't predict them from beginning. Okay, you can just have an idea, but then you can't, because it is self-evolving from the data, and the data is so complex, right? So that is also what gives these models intelligence, because then they can be unpredictable and they can be creative, and they are not limited by the linearity of our linear processes and rules-based systems, right? So, which is the good side of things. But then we need to know how to tame this beast and be able to keep things in check and to get the results that we need. So these two, train, test, split, and cross validation, they take care of things at that level of test, because you need to have the data with which to test, and you need to have different data, right? You need to ensure that it is not the same data. Okay, we'll look at that. But then regularization takes care of the trainee side of things. Okay, so these are some of the things that we're going to look into deeper in subsequent episodes, which are used to take care of this problem. And what is the problem? The problem of the the difference between the real world of our business, the real world of our business need, and the data we are able to get, right? That natural disparity that must be there. Mathematically impossible for us to get the full picture of our business world in our training data. So how we manage this situation, this is very, very critical. You have to master this. You have to be a master of this. Even if you are not in the engineering team, if you are on the project, you need to be able to think this clearly, and be able to inspect this, and even if you're a non-technical person on the project, you should be able to inspect and ask questions about this, because this is extremely critical, right? So that's where pre-processing comes in, data exploration, exploratory data analysis, where you begin to look at the data, can use pandas, and then, kind of print out some subset of the data, some part of it, and then just look at some statistics about the data, check the probability distribution of the data, check a lot of things. And then during the training process, you can also have some logs to observe, to look at what is going on, to see what percentage is being used, to be sure of what technique is being used. This has to be clearly specified, right? Because these are extremely critical to the success of your machine learning and engineering project. Yeah. So finally, this also brings the question of what is known as the empirical risk minimization. Right. So that's what all these are doing. They are helping us to take care of this empirical risk minimization. What's the empirical risk? The empirical risk is the fact that we have something that is not the real thing, right? So we cannot have data that is the full model of our business world. We can, right? We have limited observation. That is it. We have limited observation. Our data is not omniscience, So because of that, we deal with this risk. So that is what you're going to be doing. So it's a critical part of your project management when working on machine learning project. You do this risk management to be sure that, okay, fine, we have a sizable data set. At least the larger the better. But then even when it's large, you still need to do a lot of things, right? That's where we come into stuff like regularization and all that, because the nature of the data also matters for training. Because if it's not properly standardized, or as the case may be, or if you're not dealing with principal components and all that, or if there's multicollinearity, that is if maybe there are features that are kind of combination of other features, or that are related to other features and all that. There's some nitty-gritties that are coming to play even in our training, right? So regularization and some other techniques takes care of that. But in this series, we are going to program, do some coding on regularization, go deep into it, and then we'll also have the other ones, the train, test, split, and then the cross validation, which also for the test side of things. So basically, so that's that for now. Um, I wish you good luck in your AI machine learning project, and this is my first video on this channel. Um, I hope it was good, and I believe it will get better. Um, I just decided to start a YouTube channel and to share some of this knowledge. And if it is not good enough, don't worry, I'll get better at it as we progress. If you like the video, if I mean, if you found this information important and useful to you, kindly like and subscribe, and you can feel free to also share the video. So remember to turn on notification so you can see the subsequent videos that will come, because we're going more technical. Subsequently, we're going to do some coding. So that's it. Guys, have a good one. Bye.